Welcome you all in the lecture number 10 of Engineering Mathematics MTL 1025. In this lecture we will going to discuss the curve tracing. What are the different important characteristics for the curve tracing like symmetric, intercept, origin, right, asymptotes, region, right, and one example related to the curve tracing. Okay. See, what is curve tracing? Curve tracing is an analytical method in which we draw approximate shape of any curve with the help of following: symmetry, intercept, asymptotes, tangents, multiple point. One lecture on multiple point. We will take one lecture on multiple point, one separate lecture. Okay. But for the time being, we consider the multiple point, region of existence, sign of first and second derivative. Okay. Now see, what is symmetry? There are different type of symmetry. Symmetry of the curve about the x-axis, y-axis, y equal to x, y equal to minus x, about the origin, right? These things. First, see the symmetry about the x-axis. What is the symmetry about x-axis? How we know? If the equation of curve containing even power of y, right? Y occurring in even power. Power of y is even. Then the curve is symmetrical about the x-axis. Okay. See the example. Y square is equal to 4ax. See, y square is equal to 4ax. Then this curve is parabola, and this is symmetric about the x-axis. It means the shape above the x-axis is same at the shape below the x-axis. Okay, this curve is symmetric about the x-axis. Similarly, symmetry about the y-axis. If all the powers of x occurring in the equation is even, means power of x is even. See here, 2, 4, 2, right? These curves are symmetric about the y-axis. For example, x square is equal to 4ay, right? This is the parabola. This is parabola and symmetric about the y-axis. Symmetry about the x and y-axis both, right? If the equation containing even power of x and even power of y, right, in both variable even power, then curve is symmetrical about the both axes. For example, x square plus y square. See this, right? This curve is symmetrical about the both axes. Now, symmetry about the origin. If the curve remain unchanged when if we replace x by minus x and y by minus y, right? An equation of curve remains unchanged. See here, minus x to the power 5 minus y to the power 5, 5a square minus x square into minus y. Solve this equation. This is nothing but the same equation, right? Then this type of curve is known as symmetry about the origin. Then what is the difference between symmetry about the origin and symmetry about both axes, x and y axis? Every curve which is symmetric about both axes is also symmetry about the origin. Symmetry about both axes is symmetry about the origin. But converse need not be true, right? The converse need not be true. See here, if we replace x by minus x, that is minus x square minus y square is equal to a square. This equation of curve is same as this. Okay, it means this curve x square plus y square equal to a square is symmetry about the origin also. But this curve is not symmetric about both axes. Okay. Now, symmetry about the line y equal to x. Any curve is symmetric about the line y equal to x if we interchange x and y, an equation of curve does not change. For example, see this curve. This curve. Not this one. Please wait 1 minute. This is line y is equal to x. Right, this is line y is equal to x, and this curve is symmetric about the y equal to x. How we know? If we interchange, replace x by y and y by x, right? In the equation, replace x by y and y by x. If the equation of curve remain unchanged, for example, replace this x by y, y cube. This y by x, x cube is equal to 3a yx, right? This equation is same as this equation, right? Then this type of equation is symmetric about the line y equal to x. Similarly, curve symmetric about the y is equal to minus x. What is the? If we replace x by minus y and y by minus x, right, and curve remains unchanged, then this curve is symmetric about the y is equal to minus x. See the example. If we replace x by minus y, then minus y ki power 3 minus y by minus x to the power 3, 3a x minus y x minus x, sorry, y minus x. Then this is minus y cube, this is minus x cube, 3a minus x minus y, right? This equation is same as this equation, right? Then this curve is symmetric about the y is equal to minus x. Now see the region where the curve exists. It is the region where the curve exists. The region is obtained by solving y. Solve the equation y is equal to function of x. Okay, in terms of x, r, either this or x is equal to function of y. Solving y in terms of x or vice versa. Okay, the real horizontal region is defined by values of x for which y is defined, and after solving this y in terms of x, see the whether the region is exist, right? For which value of x this y exists. Right? The real horizontal region is defined by values of x for y is defined, and real vertical region, real horizontal region for values of x means this, and for real vertical region defined by the values of y for this type of, for which x is defined means x exists, for which value of y this x exists. Okay, this x is not imaginary. And region where the curve does not exist, in this one y is equal to fx, for any value of x, any value of x, if y is imaginary, if y is imaginary, right, then for those values of x, y does not exist. Okay. Similarly, for x is equal to f of y, for any value of y for which x is imaginary, for such value of y, x does not exist. Okay. Now, what is origin and tangent at origin? If in the given equation of curve there is no constant, right? For example, x square plus y square is equal to a square. Here a square is constant. Then this curve does not passes through the origin. Okay. Y square is equal to 4ax. In this term there is no constant term. This curve passes through the origin, right? If no constant term in the equation, then curve passes through the origin, right? If the curve passes through the origin, then what is the whether the tangent at origin exists? Then tangent at origin can be obtained by equating 0, see, equating 0 to lowest degree term, right? For example, see this example, right? This curve passes through the origin, yes, since 0 0 satisfy this, 0 0 satisfy this curve. Okay, then what is the tangent? Tangent can be obtained by equating the lowest degree term. What is lowest degree term? This is fourth degree term, second degree term, second degree term. Collect the second degree term. A square y square minus x square, right, plus x to the power 4 equal to 0. Then this is y square minus x square equal to 0. What is this? This is y is equal to plus minus x. Okay. These are the two tangent. Y is equal to x and y equal to minus x at the origin. For any curve, this line is tangent and this line is also tangent for this curve, whatever be the curve. Okay. Now see intercept. How you obtain intercept on the coordinate axis? Intercept on the coordinate axis can be obtained by putting y is equal to 0, right, and find the value of x, right? This gives the intercept on x-axis. Similarly, x equal to 0 and find the value of y. This gives the intercept on y-axis. Okay. The point of intersection. When the curve is symmetric about the line y is equal to x or minus x, the point of intersection is obtained by putting y is equal to x or minus x. Okay. Now, with how we evaluate the tangent at another point, say any point hk, right? Simple. We know that tangent at the origin. Then suppose this is 0 0 and this point is hk. Now shift this origin at hk by replacing x is equal to x plus h and y is equal to y plus k. Okay. Shift origin at this. After shifting, after changing this, equating the lowest degree term is equal to 0. Okay. Then we obtain the tangent at this point hk. Now see, if dy by dx is equal to 0 for any curve, dy by dx is equal to 0, then tangent is parallel to x-axis. And if dy by dx is infinity, then tangent is parallel to y-axis. Okay. Fifth point, what is asymptotes? Asymptotes, one lecture I had already taken, and some other lectures on asymptotes, right, we will discuss in any other lecture also. Okay. Then what is the sign of derivative dy by dx in the region AB? If x lies between closed interval AB, dy by dx is greater than 0, then curve is increasing in this region. If dy by dx is less than 0, then curve is decreasing in this region. If dy by dx is equal to 0, then at that point either maxima or minima occur. Similarly, sign of second derivative in this region, if d2y by dx2 is equal to 0, then curve is convex. Convex means this type of shape, means concave upward, that is something that containing the waters, that hold water, okay, this type of shape. And if d2y by dx2 is 0, then the curve is concave. Concave means this curve, right? This is concave downward and this one is concave upward, right? The point of inflection, if second derivative is 0, if at any point second derivative is 0, then that point is known as point of inflection, okay, where the curve changes the direction of concavity from downward to upward or upward to downward. Now let us see one example. Trace this curve. What is the curve? Y square a minus x is equal to x cube. What is a? A is greater than 0. It is given. Now discuss each property one by one. This curve is symmetric. Symmetric about which? Since power of y is even, right? Since power of y is even, therefore this curve is symmetric about the x-axis. Y has even power, so this curve is symmetric about the x-axis. Okay. This curve passes through the origin. Since origin satisfy this given curve, 0 0 satisfy the given curve. Okay. Tangent at origin. What is tangent at origin? Equating the lowest degree term. Coefficient of lowest degree term. What is lowest degree term? Right. Lowest degree term is y square. Putting y square is equal to 0. Y square is equal to 0 means y equal to 0. That is x-axis is the tangent at origin. Whatever be the curve, x-axis at the origin is the x-axis is the tangent at the origin. Now, what is intercept? Putting x is equal to 0. If x equal to 0, then y, what is y? Y is equal to 0. It means this curve passes through the origin. This curve passes through the origin. Okay. This curve is, now what property we discussed? This curve is symmetric about the x-axis. Curve passes through the origin. Tangent at origin, x-axis is the tangent at origin, and this curve passes through the origin. Okay. Asymptotes. See the asymptotes parallel to y-axis. Asymptotes parallel to y-axis is obtained by equating 0 the highest power of coefficient of highest power of y. That is y, coefficient of highest power of y is 2. Then highest power of y is 2. Then coefficient of highest power of y2 is a minus x. The a minus x is equal to 0 implies that x is equal to a. Okay. X is equal to a is the tangent. X is equal to a. This straight line is tangent of the curve. Okay. Now see the region. Y square is equal to, solve y in terms of x. Y square is equal to x cube a minus x. This curve. See the left hand side. Left hand side is y square. So this is even power. Okay, even power. Then if x is greater than a, then this denominator is negative. Denominator is negative means y is imaginary. X is greater than a, then denominator is negative. Okay, then y is imaginary. Similarly, if x is less than 0, then numerator is negative. Then in this case y is imaginary, right? So the curve does not exist for x is greater than a, and curve does not exist for x is less than 0. Okay, then what is the region? X greater than 0 and less than a. It may be possible x equal to 0 also. If x equal to 0, then y is equal to 0. Okay, since the curve passes through the origin. What is the sign of the derivative? Evaluate d2y by dx2. dy by dx2 is equal to this one. Okay, this dy by dx is greater than 0. Yes, it is greater than 0 in this region. 0 is less than x is less than a. If x lies between 0 and a, then dy by dx is greater than 0. Okay, then what is the shape of the curve? See, this x is equal to a is the asymptotes of the curve. Okay, the curve passes through the origin, right? X axis is the tangent. Okay, now find out the sum point. This passes through this curve passes through the origin. X equal to a is straight line is the tangent of the curve, and find out sum point. What is the equation? Y square a minus x is equal to x cube. If x is equal to a, then what is y? Y is not defined. Okay, now see some other points. Find some other points and you will see the curve is something like this. Okay, so this is the one example of the curve tracing. In next lecture we will discuss some more example of curve tracing and we will stop. Now we will stop. I will stop here. Okay, in next class we will discuss some more examples.